Welcome to the Amazon QuickSight Learning Series. In today's edition, we will be focusing in on using Level Aware Calculations to work with data. My name is Jill Florent. I'm with the QuickSight Customer Success Team, and our presenter today is Arun Santosh, the Senior Worldwide QuickSight Specialist Solutions Architect. Today we're going to talk about expanding the existing Level Aware Aggregations, which offer solutions to complex data challenges and enable sophisticated multi-level metric computations. We're going to dive into a core use case around working with data at different levels of granularity and data de-duplication, and we'll touch on other use cases as well. Because you've come here live, we'd love to answer as many questions as you have, and we'll do so in the QuickSight community, which was relaunched earlier this year. If you haven't registered yet, go to community.amazonquicksite.com, which you can get to by taking a quick picture of this QR code. What you'll find there is a number of learning resources, including a question and answer area. You can search for answers to questions that have already been asked and answered, or enter your own question. For today, if you add the tag to your new question, QLS-Level Aware, that'll allow our subject matter experts to easily find it and prioritize getting you an answer to your question. With that, I'll just call out that we are recording the session today, and the recording will be shared on our QuickSight YouTube channel by the end of the week. That is something that's a great place to subscribe to for learning content, and you can also access that through the community. With that, I'll turn it over to Arun.
Let's get started. Let's quickly look at the agenda. We'll be going through what level aware calculations are, the types of level aware calculations that's available. We'll do compare and contrast between them. We'll look at the order of evaluation, how level aware calculations, when and where they are evaluated as compared to other things in QuickSight. And then we will do a demo and look at some use cases. And I'll be sharing the dashboard link with the use cases. I have quite a bunch of use cases. We'll try to go through as much of them as time permits. And then you will be able to access those at the end. So moving on, what are level aware calculations? Simply put, any calculation that can be executed at a grain other than the display grain of the visual, that is a level aware calculation. I'm saying that can be with emphasis on can, because if you choose, you can use the same grain as that of your display. Or if there is a need, the grain can be different from your display. Let's look at the types of level aware calculations next. The first type is LAC-A. LAC is short for level aware calculations, and LAC-A is short for level aware aggregate functions, right? Level aware calculation aggregate functions. Now, what are these? These are extensions to your regular aggregates. Like you have your sum function, min, max, average. These are extensions to those functions. So you don't have to learn any new function. It just takes an additional grouping level. And this is optional. So if you were to say sum of sales, that's a regular aggregation. If you add on an additional grouping level within square brackets, like I have here, sum of sales by product, then it becomes a LAC-A function, which uses product as a grouping level. The second type of LAC function is level aware calculation window functions. Now these are, they used to be called as LAAs before, level aware aggregates before. We now call them as LAC-W functions. These are functions like sum over, min over, max over, etc. And they need a partition as well as a calculation level when you're making the function call. Like in this example, I have sum over sales partitioned by product, and then the next level is pre-filter or pre-add that drives where that calculation is actually evaluated. Now, you might be wondering, for the folks who have been using Level Aware Aggregates before, they might be wondering, you're talking about two calculation levels here, pre-filter, pre-ag. So what happened to post-ag filter, right? That's still available. We are not rebranding those. The calculation level of post-ag filter, it's still available for you to use within this sum over, min over, max over kind of functions. However, for most use cases, you would find that LAC-A functions, the simple variant here, are better alternative. But for whatever reason, if you encounter a use case where you want to use post-ag filter as a calculation level, you can. Okay, so let's move on to comparing and contrasting these LAC functions. So a LAC aggregate function, it creates an internal result set at the grouping level that you specify. And you don't have to take my word for this. We'll see this in action as we get into the demo. As opposed to the LAC-W function, the window function, the results from those functions are logically stamped on the applicable underlying detail records. The default visual aggregation for a LAC-A function is sum. So if you create a LAC-A function and you drag and drop that into a visual field well, the aggregate that shows up there by default would be sum. For a LAC-W function, that default visual aggregation is min. You can always change both of these. Either you can change that sum for a LAC-A function to whatever you want. Likewise, you can change that default min for a LAC-W to whatever you want. But these are the defaults. A LAC-A function, it handles the visual level aggregation implicitly, right? So the sum function comes in there. You don't have to worry about any double counting. LAC-A handles that for you, because it's having those intermediate or internal result set at the grain that you specified as your grouping level. For a LAC-W function, I had mentioned earlier that the results are stamped back on to the underlying data detail records. So the min aggregate function ensures that double counting doesn't happen. But if you were to change that aggregation, you have to ensure that you handle any potential double counting, you avoid that by changing the logic in the underlying calculation. A LAC-A function is meant to be used as a measure, whereas LAC-W function can be used as both measure as well as dimension. Now, there is difference between these in the order of evaluation as well. So we'll get into that next. I will not bore you with too many slides. We'll cover that and then go on to demo soon after. So in terms of the order of evaluation, LAC-W functions are evaluated pretty early, right after simple calculations. And then any filters that you apply on top of those calculations would get evaluated. Beyond that comes the analysis level filters. Then any LAC-W pre-ag functions that you specified gets evaluated. So that happens after the analysis level filters. Any calculations that you specify on top of those pre-egs comes next, followed by the top and bottom end filters. The LAC-A calculation happens after this, right? And then the aggregation happens at the visual level, filtering happens at the visual level, so on and so forth. So this is something which you need to keep in mind when you're deciding which calculation to use. So if you were to ask me which is better, LAC-A or LAC-W, there is no right answer for that. It's not one or the other. It depends on the use case. Depends on what you're trying to do. Is it something that you're trying to just do at visual level? Really simple ones where evaluation needs to happen at the very end. Possibly LAC A is a good fit for it. If you want to do more complex calculations and you want to also use that to feed a dimension, then LAC W function is possibly the right fit. And then if you want to control where that calculation happens, you want to do it ahead of filtering, like you are taking the total value of sales across all products to be used as a denominator in calculating a contribution percentage. So you want to do a pre-filter calculation there. You would need LAC W for that. So it depends on the use case, and we will give you this. We'll take you through the samples to give you an idea of what gets used where, and that will help you in making your own decisions. Okay, so with that, let's move on to looking at some of these demos. And like I mentioned, I'm just in an analysis view here, but I'll share the dashboard link with you. And don't worry about any of the text here. Just try to follow along on what I'm saying. So herein, you will see I have some different variants of these LAC functions defined, right? So I have a LAC W pre-filter, which is summing up all the sales across the full data set. When I say across the full data set, I mean I haven't put any partition. So it would be something like this. The partition field is just empty, right? So it does the aggregation across the full data set. Now, pre-filter, pre-ag, post-ag filter, the old variant of LAA, and then the LAC A function as well. Right now, you can see that when I'm looking across the full product, the sales gives me this sum of sales for each product, and overall sum is 2.29 million. And herein, I chose to get the data set level aggregation, and that's being displayed across all the rows, because that's what we are asking QuickSight to do there. Now, all of these are giving me 2.29 million. Then what's the difference? Right? That will become apparent as we play with these filters. So I had told you about the order of evaluation where each of those things happen. So let's see that in action. Let's say we uncheck a couple of these products. Now you can see the plain sales column, its total dropped down to 1.9 million now, 1.95 million. The pre-filter, it stayed at 2.29. It stayed at the original sum of sales across the full data set. This filtering, which is happening at the analysis level, it didn't impact this pre-filter calculation. So that comes in handy when you want to ensure your denominator doesn't change based on the filters. Versus the pre-ag, post-ag filter, and the LAC A sum, all of those you can see their values changed, right? And right now you will see that the total for LAC A sum is empty. That's one of the limitations that's called out for LAC A calculations. The total row and column totals don't show up currently. That's something which the team will be adding on as part of the next iteration. In fact, in my instance here, I can see that when I am in select all mode, right? When there is no filter applied, you will see that the total comes in. But gradually, with the next iteration, that total will start to work even when filtering happens. So we saw the effect of a filter. Now, when we looked at the order of evaluation, we had seen that after the pre-aggregation, there is the top bottom filters happening, and LAC A comes after that. So let's play with that here. We have this top end filter. We had 14 products. Right now, it's set to show all 14 products. So let's say I take this to 8 products instead. Now you can see that the post-tag filter as well as the LAC-A, those drop down further. Instead of 1.95 million, we are having only 1.8 million there. That's because we are showing only the top 8 products here, right? So this should give you a good idea of how the order of evaluation matters and which functions to use for your use cases, depending on what you're trying to do, right? And then when comparing and contrasting these functions, I had also told about the default aggregation being used. So you can see here, I have marked those here. For the pre-filter, post-tag filter, the default will be min, and for the LAC-A, it's sum, right? So I have another visual down here wherein I have explicitly added duplicates of this pre-filter as well as pre-ag. And then I have changed those to min and count. So now we can see all three, right? Min was the default. I have duplicates here with count and sum. Likewise for the pre-ag, right? You can see when the sum is brought in, the value is very much inflated. Why that's happening? It's because these value, the 2.2 million that's calculated, it's stamped back on the logical records, which we had 9,994 994 here. So it gets multiplied by as much, and that's this number, right? Likewise for the pre-ag. Versus when it comes to the aggregate function, that's an internal result set that it creates. So when you're saying compute the sum of sales across the full data set, it does that and it comes out with one record. So you can see here for the LAC-A function, the count is 1, which is why the default aggregation applied is sum and it still comes out correct, right? And let's get this into Excel and we will confirm that the calculation is all holding good, right? So this value I said is this 2.2 million multiplied by the row count. Let's confirm that. So times B2 times C2, and let's put the same formatting there. And you can, oh, where did I put it under? So you can see the value. Hold on. Pre-filter. I put a wrong calculation there. I should have done it here, right? This is the value, the sum, and I had said it's this amount, the minimum value times the pre-filter count, right? So let's do that. So D2 times E2 is what we are going after. And let's put the same formatting. So you can see it's an exact match. So this number would be the same, right? So equal to G2 times H2. And then if we apply the formatting, that would be the same. Good. Okay, so that proves that point. Now let's look at some more use cases, right? So we have about 12 more minutes. I'll take you through as many examples as we can cover, and then I will be sharing the link of this dashboard with you. So let's look at actual versus target. So this is one use case wherein, let's say you're having the product sales in one data set, and you have yearly targets for each of the products. So the grain of that is year and product, but grain of your sales data is much lower than that. You have daily sales coming in, right? So you can bring your targets onto the sales data set, but that target amount is going to repeat across multiple sales records. So if you were to just sum it across the board, you would end up double counting and it wouldn't be accurate. So how would you do a comparison of your actual sales against the target, right? So for that, you can utilize LAC-A calculations. So here I'm creating the product yearly target as a min of my target amount. Now this is repeated like I mentioned. And I'm saying group it across product and across the order date truncated to the year, because I know this is at a product and year green, right? So I bring it to that green and take the minimum. So if I had 1,000 records for one particular product through the entire year, rather than getting 1,000 multiplier, I'm taking the min value out of it. So I'm getting it only once, right? And then we can use it with the default field well aggregation. So in here, in this visual, if you see, it's plotted here, the product yearly target, the default aggregation is sum, and then the actual sales against it. And those show up correctly. And likewise, at a product level, if I want to use it, I can do it grouped by product. So let's, and then down here, I have a table which shows the same, right? So it shows me my sales and product yearly target. And it also shows the actual target field itself. So each field is coming in with the value 11,000 for this particular row, Alchemy 2019 target. But there are 10 rows, so if I were to directly sum up the target, it would become 110,000. But then the product yearly target calculation stays solid at 11,000, right? You can try filtering these across as well. So if I want to focus on 2022, clicking on it, I have filter actions going, so it gets the other visuals filtered. So you can play around with that further when I share this. Moving on to average of top product sales. Let's say we have a scenario wherein we want to find the top sale that was made for each product within each country. And then we want to find the average across those top sales within each country and want to display that. Right? To find the top sale at a country and product level, we can use a simple LAC-A calculation here. We will use max sales grouped by country and product. Right? So it will give us the results like this, which is shown in this table, top sales per country and product. You can see there are multiple rows coming in for Argentina, one per product, and you see the max sale within that for each product. Now we want to do average across these. That can be quite easily done on this map visual by bringing that top sales per country and product into our field well. And then we are using an average aggregation on top of it, right? So here, let's say if I were to click on United States, it's showing me the average is $2,958.82. And the table here has been filtered down for United States. So let's get this into Excel. We'll just verify the calculation. So you can see here that there are 14 rows, and if we go across that, the average that shows up here, 2,958.82. That's what we showed from this map using our LAC-A calculation with an average aggregate. That's working good. Let's look at another use case. Let's say we are wanting to compare products side by side, right? So we want to see how one particular product is faring compared to another. A regular bar chart like the one that's shown here can do the trick. It tells me that Alchemy right now is sort of middle of the pack. Data Smasher has got more sales, Support has got less sales than this. But then if I want to see how much was the difference, I have to calculate sort of the difference between these bars. So it would be good to see that called out as well. So that's what we are showing on this right-hand side chart. So our data smasher had 17K more in sales versus support had 24K less in sales as compared to Alchemy. So how can we do that, right? So that's something which we can tackle using our lack window functions. So we could do that comparative product sales. We can do sum of sales, which gets us the sum of sales for a particular product in context. And from that, we can choose to subtract the sales for a selected product. And that's what we are doing here. We are saying if else product equal to this parameter, which has the value of our selected product, then bring in its sales, otherwise zero. So in effect, a sum over of this across the full data set at pre-filter level will get us the sum of that sales for that selected product. And then we are going to subtract that from the sales of the product in focus. So let's say click here, the navigation actions have been set up to change the product parameter. So it now becomes big old database, right? So out of this equation now comes with the sales for big old database. And then the left side gets it for each of those actual products. And hence we get the difference, which is plotted here. And then we can plot the color as well, right? Anything that's positive is green, anything that's negative, we want to show in orange. So that's where we put an if else on top of it. And then we say whether it's positive or negative, use that to drive the color field well. Let's do a quick time check. We have 4 more minutes, so maybe we can cover 1 or 2 more. So looking at cohort analysis, right? There are several scenarios where we want to analyze our customer loyalty, right? So if we have customer order data, we can look at when was the first order placed by a customer. And based on that, we can sort of try to look at, are we retaining customer loyalty, right? Are our earliest customers spending more compared to our newer customers? So to do that kind of a cohort analysis, we can utilize our lack window function, min-over, right, to get the order date, partition by customer ID, pre-filter. So it gets us the date of the first order that a particular customer placed. Now, using that, we can add it to the group field well, and then so here, and we can set the aggregate to year sort ascending. So we get these separate bars based on that, right? And then we are having the actual sales brought up here. And that way we are able to divide that into separate cohorts. And in this particular data set, we can see that our oldest customers are spending more and more, which is good for business. We are treating them well. They are staying with us and pulling in more and more orders, right? So that's the pattern we want to see. Now, we might want to look at new customers that we are accumulating, right? So over time, we want to see how many new customers we are getting. We can do that again using min-over function, similar to what we did in the prior cohort analysis. We can find the min-over, we can use the min-over function to find the first order date for a particular customer. And then for the records that match that date, we can bring out the customer ID. And for other records, we can bring out null. So meaning to say, we will consider the customer ID only for the first day a customer placed the order, right? And then we are doing a distinct count on top of it. Then doing a running sum sorting it by date, and we can partition it by customer region here. So you can see I get this running sum for APAC, EMEA, and US. And as the number of customers, new customers increase, you can see that number goes higher and higher. Since we are using distinct count, we don't double count any customers here. Okay, so we are right about at time. I have a few more samples here that I will let you explore at your own pace. So let me give out this link to you. This is available on Demo Central. So let's go to Demo Central, Learn QuickSight Online. This is a public facing site. You don't need any credentials to come and use this. Go under Feature Demo and look at Calculation Level Aware Calculations. So you can access this dashboard. It has all the tabs, or everything that we covered and the other ones that we couldn't quite get to. And if you want to look at the underlying analysis, like I was demoing from my analysis view, you can just hover your mouse to the right side, bring up this sidebar, click on that analysis icon there, and it will load a temporary view of the analysis for you. So you get to play around with it. You can look at the calculations, you can make modifications. Feel free to mess around with this. Don't worry about breaking anything because it's a temporary view that you're getting. And after your session is done, it will be wiped clean. So use this Demo Central analysis feature, feature demo, and level aware calculations. I'll see if I can put that back on the slide here in a moment. Yeah, that's the full link, but if you can't get to the full link, just remember Demo Central Learn QuickSight Online, and then you can always traverse from there by going under Feature Demo. Okay, so that brings us to the end of today's session. Thanks for spending your time with us today. I hope this gave you some good insight into how to use level aware calculations, the power it brings, and the various scenarios it can solve for. We'll be adding more and more features around level aware calculations. And as we do, we'll bring out more webinars and keep you in the know. So have a wonderful day ahead. Talk to you folks later. Bye.